with number 1, just like a normal combining like terms, this one just happens to have all fractions. We're going to distribute the fraction to everything. So just be careful, double check your math. Use your calculator if you need to. Here we're multiplying 2 times 1/6. So that would be 2 over 6, or 1/3. Negative 3 over 6, or negative 1/2. And then here, because these go into each other, 4 over negative 2 would be a negative 2x. 6 over negative 2 would be a negative 3. Just 3, not x. And then the last part would be 2 times 3, so 6 over 3 is 2x. And then 2 times negative 9 is negative 18 over 3, is negative 6. Then we have to combine all of our like terms. You have a bunch of x's. You could do this in your calculator, but we have this negative and positive 2x, so those are going to cancel each other out and just leave 1/3. The constants, I'm going to add that in the calculator. So negative 1/2 minus 3 minus 6. Would be negative 19 over 2. So if you got that, that was the correct answer. So 1/3 x minus 19 over 2 was our final answer for that one. We don't usually get fractions, but that one we got a fraction. It happens sometimes. Questions on that one? You may have seen problems like this before in 8th grade, because I know you talked about solving, but I don't know to what extent. But we're going to do some more solving today. So if this were a normal combining problem, we would distribute the negative out in front. So let's do that. Not that well. Okay. And then with solving, our goal is to get the variable by itself. So we have 2 right now. We need to combine like terms. And then still get the variable by itself. So get rid of the 4. And we would do that by subtracting to the other side. If that part doesn't make sense, we're going to talk about more of that today. But that should be something you've seen before. Not in class, but in 8th grade.
Is it okay if the answer is a mixed question?
I would say leave it as an improper instead of a mixed. Alright. Questions on that one? Everyone look at your calendar, the gold sheet of paper. There are a couple things I want you to look at and notice. One is your Khan Academy quiz dates when they're due. So as I said earlier, the next ones are due next Friday, even though we don't have school, even though it's a holiday, because whatever we do today is being pushed to next week. The date after that is the following Friday, the 18th. The date after that is a Tuesday because of Thanksgiving break. So keep those dates in mind. You'll also see that the Monday before Thanksgiving break is our next flex day. If you are not here that day, you miss that chance at a flex day. So then you'll need to come before or after school to work on that stuff. And then also notice that when we get back, we'll be taking our Unit 4 quiz, because it's collaborative. You guys can work with each other and talk to each other about it. And then that Wednesday after we get back will be your test. Anyone have any questions on any of that? The green book that was with your stuff is like the exponents book from last unit. Use it to review, use it to practice, but also hold on to this for a few units. We're not going to use it in the next unit. We'll use it this unit, not in the next unit, but then when we come back to equations in a couple units, this will be helpful again. And then when we get back from lunch, we'll start our notes. So if I asked you, what is a solution, what comes to mind? Say that again. The final product, okay. Anyone else have a different answer? Not that that's wrong. Okay. So we can say a solution is the final or the end result. Let's say that. But the end result of what? An equation of a problem. Okay, so a solution is the end result of an equation or a problem. This next section, we're going to be given equations, given solutions, and we have to determine, are they solutions or not? Is anyone still writing this part down? Okay, anyone still need this part? So if we were given this equation and this solution, how would we determine if this is a solution or not? What do we think, Hannah? Like at the end. Okay, how would we find if they're the same at the end? What would we do, Nature?
Substitute the x for 5.
So basically we're evaluating our solution to see does it work or not. So we're going to put 5 in for x. And then we're going to figure out if at the end they're the same. If they are, it is a solution. If they're not, it's not. Oh, before we continue. This section is going to be split into a calculator versus non-calculator. Some of the problems you'll have to be able to do them without a calculator. Some of them you'll have to be able to do them with. All of them, I would just say practice some with, practice some without for this section. 13 times 5 would give us what? 65. And then if we subtract 7, what would that be? So because these are the same at the end, we can say this is a solution. Or this is the solution, it works. So when we test this, we're trying to get a true statement at the end. 58 equals 58, that is a true statement. Right, questions on that one? For this next one, we know that 5 is a solution, so negative 5 probably won't be a solution, but we're going to test it anyway. here, this will give us a negative 65. And if I subtract negative 65 and 7, we get what? Negative 72. And do those two equal each other? No. Negative 72 and 58 do not equal. So this cannot be a solution. Questions on that one? I want you to try 3 and 4. I'll give you a couple minutes to do that. And then we'll come back and we'll talk about those two. For number 3, did we find that that was or was not a solution? Was not correct. Does anyone need to see that one? So that was not a solution. It did not work. What about number 4? Was that a solution or was that not a solution? Yes. It was. Does anyone need to see that one? So this is a good check that you can either do in the calculator, by hand, either or. That once we start solving, to double check to see, does this actually work? Is this actually my solution? Or did I mess up somewhere? I forgot a negative or something added when I was supposed to subtract and I didn't get the right answer. All right, questions on any of that? Move on to the next page. So I imagine that at some point you talked about these, but I could be wrong because I don't know what you do in 8th grade. So in order to solve, you have to know your properties of equality, where what you do to one side you have to do to the other. These are your different properties of equality: addition, subtraction, multiplication, division. Can't speak now. Distributive property, there we go. Isn't done to both sides, but you do it so that both sides are equal. All of these things kind of balance out the equation. So with these problems, these are already solved for us. We are just going to describe what happened between each set of steps. So let's start with number 1. This first one is given. That's just your equation. Then we're looking at from step 1 to step 2. What changed? What happened? Iman. Distribute. They did distribute. Let's not do that color. Which is how we got this. So that would be the distributive property. I'm going to shorten some of this. And then looking from step 2 to step 3, what did they do there? Lily? They added to both sides. So that would be your addition property of equality. Again, I'm going to shorten that because I don't have enough space to write all those words. And then in step 3 to step 4, what happened there? Say that again. Division. You divided both sides by 2. Usually division is your last step in almost all of your problems, but sometimes it's multiplication instead. Or, depending on the problem, it could be adding or subtracting. It depends. Questions on any of those? Yes, Josephine. So, not at step 3, it's what we did between the steps. So, from step 1 to step 2 is distributive. From step 2 to step 3, we added 18. So, these match the steps, not the numbers. So, we're looking at what happened here, and that goes here. No, that's not. Okay, what do you confused about? Confused about that here. When we're solving, we have to do inverse operations. So we're subtracting already. So to undo that, we have to add 18. So we're undoing whatever is given. Right here. We you have to get rid of 18, and the only way to do that is to add it. We're going to do more problems with inverse, and hopefully it'll make sense later. We're going to skip 2, do 3. The first one is given. From step 1 to step 2, what do we do? Go ahead and do step by 2. Multiply both sides by 2. So that would be your multiplication property of equality. From step 2 to step 3. We added what? 1 to both sides. And then step 3 to step 4. Go ahead, Christian. Division again. Divided both sides by 5. Questions on that one? I'm going to give you a minute. I want you to try number 2, and then we'll come back and talk about it. Alright, from step 1 to step 2, what did we do there? Go ahead, Victoria. Say that one more time. What did we subtract? Right, and then from step 2 to step 3, Christian. Multiplication. I cannot speak today. So those are the 2 you got. Pat yourself on the back. That was correct. Questions about that one? Okay. Let's move on to the next page. Alright, so this question kind of goes back to the first question I asked. What does it mean to solve an equation? So if I ask you that, what would you respond with? Lily?
Work out each step in the equation.
Okay. Work out each step in the equation to do what? Think back to our first question. To do what, Nature? To find the solution. We could be a little bit more specific. The steps you're talking about are inverse operations. So we can say, use our inverse operations to get a solution. So use the inverse operations on an equation to get a solution. I'm just being more specific. Use the inverse, use the inverse operations on an equation to get a solution. So speaking of, let's talk about our inverse operations just so we're all on the same page. So if we think about what is the opposite of addition, or how do we undo addition, or what is the inverse of addition, what would that be? Go ahead, Cameron. Subtraction. So I'm just going to draw arrows between these. What would the inverse or opposite, or how do we undo division? Lily? Multiplication. Anyone still writing the sentence? What is the inverse or opposite of squaring something? Annabelle, were you going to raise your hand? No? Okay, Hannah? Square root. So if I have like 2 squared, that would be 4. The square root of 4 is 2. They undid each other. So then cube root and cube are inverses as well. 2 cubed is 8. The cube root of 8 is 2. They undid each other. So take a second and read this either on the board or on your paper. Right. This is like your rules to fall back on. If you're not sure, where do I start? Look and see, do you have parentheses? Can you distribute? If not, move on. If you have like terms, see if you can combine them. If not, move on. Your goal is to get the variable by itself. So we're going to do that by either moving the constant, adding or subtracting, or whatever the problem says. And then usually the last step is multiply or divide to get the variable by itself. So I want you to look at this page, look at all the problems. Find problems that you're not sure where to start, it looks challenging, you just want to go over it, you have questions about it. Any of those, and tell me which ones. Mm-hmm. 9. I'm just going to circle all of them and then we'll go through Victoria. 3. Cameron. 6. 6 is going to be the last one we do out of all of them. Any others? Lily? 8. Just 2. We got 2, 3, 6, 8, 9. Any others? Alright, so we'll start with those. Start at 2, go our way down, and then do 6 last. So with a lot of these problems, there are multiple ways to do them. It's your preference as to which one or which way you choose. So we'll do one way and then the other. For this, we're trying to get m by itself, so we need to get rid of the 4, get rid of the 2. What do you think we should do first? Victoria? Subtract what?
2
So we can subtract 2 on both sides. Remember, what we do to one side, we have to do to the other always. So this would give us 8 equals m over 4. And then to get m by itself. Hannah? Say that again. We're already dividing. Lily? Multiply both sides by 4. So since we're already dividing, we got to do the opposite. So this would give us 32 equals m. And then we want to make sure this works, that we didn't just solve it and get an answer that may have not worked. So if I put 32 back in, 32 divided by 4 is 8. 8 plus 2 is 10, so that works. It is a true statement. So that would be one way to solve it. This would be the other. I'm going to rewrite it right here. Some of us see fractions and our brain goes haywire, and we want to avoid the fractions or get rid of them. So this would be us getting rid of it. Because this has a denominator of 4, I can multiply this entire side by 4. But what I do to one side, I have to do to the other. So I'm not breaking any math rules or laws. And then what's going to happen here is I'm going to distribute. So this becomes 40 4m over 4 and 8. The 4's cancel. This is leaving m. And then we could just solve. It looks a little simpler than the fraction we had. You get the same answer, it's just done a different way. So it would be your preference. Whichever one makes more sense to you, do that. Yeah.
For the n divided by 4, could you just like multiply by 4 and do it on the other side, or does it have to be just
You would have to multiply the entire side by 4. Yeah, because if you just multiply like this part by 4, this won't be accurate and you'll end up with the answer. Right? Other questions on that one? Let's look at 3. What would be our first step? Go ahead, Victoria. Addition. What are we adding? So that would give us 2 over 3p equals 140. And then to get p by itself, what would we do? Go ahead, Victoria. Okay, so I don't know if we said this in here or not. We don't, in math, like dividing by fractions. So normally, yes, you have some number here, and because these two are multiplying, you would divide. But if I were to do that in the calculator, one, that doesn't look nice because I have a fraction within a fraction, but let me show you what happens. So I'm going to do 2 sets of fractions, 1 with 140 in the top, and then in my denominator, I'm going to add another. So again, it doesn't look nice, but when you divide by a fraction, you end up with something bigger than what you started with. The reason it does that is because it's really taking this fraction, flipping it, and multiplying it on both sides. So if I were to put that in my calculator instead, you get the same thing. So instead of dividing the fraction, flip it and multiply the reciprocal by the reciprocal is what this process is called. Questions on that one? Six we'll come back to. Let's do 8. What would be our first step? Go ahead, Lily. The -3 to everything inside. Be careful with your signs, because you're going to have a lot of negatives. So make sure you're multiplying correctly. Double check yourself. And then our next step. Nature. What are those like terms? Okay, so if we combine those, that will give us a -5y. Then the problem looks similar to some of the others, where we just need to add or subtract and then divide. So then from here, what would we do? Victoria, go ahead. Subtract 21. And divide everything by -5. So if I wanted to double check myself, I didn't do this for the last problem, but I'll do this here. I can put this back in for all my y's, but I'm going to put it in my calculator 2 different ways. I already forgot what this said.
11 minus 7. Oh, shit.
Okay, so when I put negative 11 in, I see that I get 76, which is what it equaled, so this is a true statement. Another way, and I feel like I showed you guys this, but I don't remember. I could take that same thing and actually set it equal to 76. So if I want to do that, I gotta go into second math, and then find the equal sign, and then put in 76. And the calculator will give me a 1 or a 0. 1 is you did it correctly. 0 is something's wrong. The only bad thing is the 0 doesn't tell you what is wrong, so it could be anything. But this is correct. So that is our answer. Questions on that one? Nine is similar, where we are distributing the negative 5. This becomes a negative 50. When we combine, our like terms, that would become what? Not negative 1. Okay, then we can add 50 to both sides. And divide. Divide that, tell me what you get. Christian?
16.
Did we all get 16 or negative 16? You should get negative 16, yes. Alright, really quickly, I'm going to put this back in, make sure it works. 4 times negative 16 minus 5 times 3 times negative 16. So that works. Alright, 6 we'll go back to, and then there are 2 different ways to do 6. More space then. So just like one of the other problems, we can either deal with the fraction or get rid of it. So I'm going to show you both. First way, we're going to deal with the fraction. If I wanted to add these two, right now I can't because they don't have common denominators. What common denominator could I change them both to? 6. So if I want to change this to a 6, I'd have to multiply it by 2. What I do to one part of the fraction, I have to do to the other. And the same thing on this side. So this will become 4 over 6 and 3x over 6. From there, because we now have the same common denominator, we can combine our fractions. And because everything is now one fraction, we can combine our like terms. And then you have a choice of either multiplying both sides by 6 and then divide it by 7. So it'll look like this. Or you could do them both at the same time. This is really 7 over 6x. So I could take this and flip it and multiply that on both sides instead. Let's rewrite. So it actually is. One has 2 steps, one has 1. They're both doing the same thing though. So that would be method number 1, keeping the fractions, dealing with those fractions. Do you have any questions about that? Then I'm going to write it again. If you have space next to it, you can write this. Or if that way made sense, you don't need to do this. The second way, getting rid of the fraction. Just like when we multiplied both sides by 4, we're going to do the same thing here. But whatever we multiply both sides by has to be a combination of these. So the 6 we used before, we're going to use that again. And because I multiplied 6 on one side, I have to do it to the other. So then, again, I'm going to distribute this to my numerators. So this becomes 12x over 3 and 6x over 2. So right now, we still have fractions, but we can simplify. Because this would become 4x, this would become 3x. And we can combine our left terms and do it. So whichever way makes more sense to you, you would do it that way. Both would get the same answer as long as the work is correct. I don't think I put this back in to make sure it works, but we can do that real fast. Let's see, 6 times 2 is 12. 12 divided by 3 is 4. 6 over 2 is 3. 3 plus 4 equals 7. That works. Do we have any questions on this problem? There's one more. I'm going to show you this real quickly, but we're not actually using this. Go to your next page. This is more for two-step equations where it's just one number in front of x and then something else and it equals. So if you have an equation like this, you can use this if it helps you, but a lot of our equations will not be in this format, so it doesn't really help us. But the way this works is you have an equation, and the steps match the equation. So we start with the variable, pick a number, that's your variable, and then it's saying what you did to the variable. Multiplied it by 7, added it to 5, or added 5 to it, and the result is 26. So that explains how we got our equation. The next part is actually solving it, putting it into words, what we're doing. So we would start with the result, we would subtract 5, and then divide both sides by 7. And they're looking for the answer, the result at the end. The check part, these first 2 lines is the answer in math form. So we start with 26, we subtract 5, then we take that number and divide it by 7, and 3 would be our result. The very last part is just double checking to see does it work. And it does. So if you want to use this process, the steps are there for you, but again, we're not going to do this a whole lot. We're going to do one of these today and then do more next class. So go to this page. And we're going to do number 2. So the solving was one objective. The word problems is a separate objective. With any word problem, I would say circle, highlight, underline, anything you find important. So let's read it first and then we'll find important things. To mail a first-class letter, the U.S. Postal Service charges a flat rate of 53 cents and 18 cents for each ounce. It costs $2.69 to mail your letter. How many ounces does your letter weigh? What do you think is important from that? Hannah? Okay, 18 cents for each ounce. So Leah, say your name.
The $2.69 to mail
Anything else we think is important? Iman? The flat rate of 50%. So anytime you see numbers, those are usually important in a word problem. And then the question, what are we looking for? Go ahead, Taylor.
How many ounces does the letter go in?
So then when we start the problem, I would say start with your question, because that's going to help you figure out a variable. The question is something you don't know. Variables you don't know, the numeric value. So you're going to pick a variable, whatever you want, but I would say avoid O, so you don't mistake it for a 0, avoid S, so you don't mistake it for a 5, and T for a plus. Anything else for a game? I just probably use X a lot. If you don't want to use X, use whatever you want. And then we have to be specific. So we're defining what this variable represents. So ounces, yes, but it represents specifically the number of ounces. Because we want to be specific because some of these will represent cost or number of, so we need to know which one are we looking for. And then some words to help you in a word problem. If you see the word for each or per, P-E-R, that's going to tell you you're multiplying. And usually whatever it says is what you're going to multiply to. So 0.18 times the number of ounces. Those two things are going to go together. Flat rate is something you get charged one time, no matter anything else. So if this doesn't weigh anything, you will still get charged with 53 cents, no matter what, which is unfortunate. So we have to somehow come up with an equation with these numbers. Anyone want to use these numbers and take a guess as to how we might set it up? Mom, are you going to raise your hand? Yeah, go ahead.
0.18 times M.
I'm going to use X, but yeah, M, whatever variable you use.
Minus 0.53.
Now, are we subtracting this from this? This represents our total. So would we subtract this?
And
then equals 260. So you'll have to define your variable, set up your equation. After you do that, solve the equation, and then get your answer. So what would be our first step? Subtract the 0.53. Be careful with your decimals, don't lose them, otherwise you're subtracting 53 instead of 0.53. It gets confusing. And then our next step. I did see your hand. Divide that, tell me what you get. Just like our variable, we have to be specific with our answer as well. 12 what? What are we looking for? Ounces. Number of ounces, so 12 ounces. Alright, so we're going to break there so you guys have time to practice. So I would say try any of the problems from the page that we were working on problems, anything that's left over. I do want you to see if you can try this number 3. All of these pieces and parts go with number 3, so I would say try all of that. If you need my help or have any questions, let me know. I'll be around.